Alright, this is a recording for Chapter 6. I'm not going to be giving this in the normal full screen mode, so I want to bring some other stuff up on the screen during the recording. Sorry I didn't record something for Chapter 5, but I've been sick for the last couple weeks. Alright, here we are. Chapter 6, or Lesson 6, Wireless LAN and IP Network Threats and Vulnerabilities. Okay, we're going to talk about what each one of these are. We're going to talk about some different concepts that pertain to them. Alright, first of all, their little chart here basically talks about skill level of people and who are inside or outside. Obviously, we always know the insiders are the worst threat because they have access into the network. Okay, so like we have an insider with highly skilled would be very difficult to prevent because he's inside my network already. I probably couldn't detect him, but an outsider with highly skilled as well. Says most can be prevented with a firewall. Since they're not inside my network, I can probably keep them out. But an insider not skilled, well, then we can still have an issue with basic attacks, script kiddie type stuff, and we'll talk more about that. But really, an insider is the biggest issue, whether they are skilled or not, because they already have access inside your network. Okay. Targets. Now, if, I saw a video a couple weeks ago where this guy had, I guess there's a real popular type of shoe out. It's all red. It looks like really thick rubber. Well, these guys left these shoes out by trees with video cameras recording them. And people would run up and actually steal the shoes. And they would go after and talk to them. Why'd you take the shoes? And there was also one where they did it with a bicycle. Point is, it's a target of opportunity. The shoes were sitting there in the open, so people are going to take them. You can think of the same way when it comes to cyber and about our networks. I mean, if you've got a machine that's not protected, that's a big issue. Okay? So, specific targets with highly skilled people, that could have devastating effect. Okay? So, it really depends, what are they after? What was it, the OPM release, or OPM break-in lately, they said that the Chinese, or whoever did it, I forget who they said, I think they said Chinese, were actually in our network for multiple years before they were detected. So who knows what they did during that time. Okay, now, 802.11 is wireless, easy enough to think, we all know that, okay? Since attackers can capture and analyze packets. Now, what I brought here is, let me find it. I got a Wireshark right here. Okay, what I did was I just happened to start capturing some packets up on our vSphere network. Okay, and at the same time, right here, I ran a ping against my cell phone, which happens to be connected to the same network. Okay, so just because I was pinging it, you can see the actual traffic here. Actually, let me start again so you don't think this is fake. Okay. Come on, start. Capture, options, ETH0, start. Don't save. Okay, so I'm going to do the ping again. Now you'll actually watch, this is live traffic, and you'll see the ping request and replies coming through. ICMP. Okay, now I'm going to stop this. Okay. Oh, my phone's off. Hold on, let me wake my phone up. Make this easy. There it goes. Okay, so let me capture a little bit more now that my phone's actually awake so we can get some data. It got a few, but it didn't get the answers to them. Here we go. We're going to start some captures. Now we have some requests and replies. Okay, so let's just get a few. Okay, now I'm going to go over here and stop this. So even though this technically is on a wired network, how do we know it's not a wired connection that's scanning a wireless connection? Okay, so let's look at some of these. Here we get a request and reply. The way this works is I send a request from this machine, this Kali machine, to my device, and it replied. Okay, so it came from 10.10.40.163, which is this machine, and the destination was 10.10.40.58, which happens to be my current IP on my cell phone. Now, if you actually expand this down here, you'll see the destination right here is actually an Apple device. Okay. So we can tell very easily that we have connected to a mobile device, even though we're on a wired network. Now, if I look at other traffic here, let's see if we can't find, there's got to be something else on here. Let's see, is there any other type of broadcast traffic that I really didn't get a lot? Got a little UDP traffic, but You'll notice there it's all broadcast, so we're not going to, that's just from a VMware machine broadcasting. Because I didn't do anything else to generate regular traffic. But my point is, this is just like if you were accessing a wireless access point or your router at home, because you can still see the wireless traffic. Because I'm connected to a WAP in my office, which happens to be on the same network, and you can tell right here. So there, you'll see the source is VMware, the destination is my phone. The reply, the source is my phone, the destination is VMware, so it's actually a packet coming back to me. Now I could have very easily ran Nmap. I could actually, let's do that. I'm going to bring up, let's look into information gathering, and my is 40.58 is my number. So I'm going to go 10.10.40.58. Now I'm going to do an intent scan of my cell phone. So what's happening now is Nmap, or ZenMap, which is actually running Nmap. ZenMap is just the graphical version of it, is running a scan against my actual phone. Make sure that's my number. Yes, it is. And it's going to do a few things. Actually, I should have probably run a quick scan. Would have been a little bit quicker. Let me pause this for a second until it finishes. Okay, I stopped it and started again. I did a quick scan this time. And you will see I scanned the same phone, the same IP address. So make sure that's mine, 10.10.40.58. I did a quick scan. It changed the Nmap command there. And, oh heck, hold on. Alright, let's resume. Sorry about that. We just had a bomb threat in our building. Yay! I guess someone left a backpack in the women's restroom that said free to a good home, and I don't know. Well, kicked out of the building. Either way. Alright, so let's continue where we're at. Again, that was my IP address. I ran Nmap on it, and you can very easily see here that it did return an Apple device. Mine really doesn't have any ports open, is why it's not showing anything here. Now, if I went over to port details, come on, it's not going to show much. Yeah, there it is. It's going to show my MAC address, and if I actually looked that up, you would see that it's an Apple device. Okay, since I did not do an intent scan, it's not going to tell me a lot more about it. Okay, all right, let's go back to, sorry about that, I got all confused. Okay, so what can happen is people can capture your traffic. Think about it, you're sitting there in IHOP or McDonald's or somewhere. Someone could very easily be sitting in there with another wireless device and actually be breaking into your phone at the same time. Now, some devices are more susceptible than others. For instance, Apple seems to be more secure than Android, which is, the Android has a lot of issues. Now, if you do root your or jailbreak your Apple, then you have an issue. Okay, so it says attackers can capture and analyze packets traversing the air interface. Now, I did just show you that. Showed you right here, you can very easily see packets. Now, I don't have Kane installed on this machine, so I won't be able to show you a man-in-the-middle attack, but I'll do that at another time. But if I did, I could actually basically be capturing all of the packets from my iPhone on this device. I just don't have that installed at the moment to do it. First of all, it won't run on Kali. Okay. It says attackers may also scout individual employees to see when they live and spend their free time. They can watch you. They can see what they're doing. They can do just basically all kinds of stuff. Okay. All right. Let's move on. All right. Physical security. It says control radiation or RF signals outside the premises. Now, kind of funny thing about that, we have wireless access here at Rose State. Okay, it's free. People can just use it. But our windows have this metallic tinting on it, so really outside they don't do as much. Like our cell phones kind of suck inside the building. Okay, now you can actually get coding kind of like a Faraday cage, and if I look up, bring Mr. Google over here, look up a Faraday cage, a grounded metal screening, and this should show us some examples. These are cages. See, this guy is not getting touched at all there. When I was actually up at the FBI headquarters in Louisville, Kentucky, they actually had a bag. There it is, a bag made out of this stuff. It's actually, theirs is a little bit thicker than that. What they would do is they would put mobile devices inside of it. You could see through it, but it had a metallic screening that no one could get in. And there's actually a movie, Enemy of the State, Should be Lex Luthor involved in it here. Will Smith. You know, who's in the darn? There it is. Gene Hackman right there. Lex Luthor. He was in there, and he has a very large. Let me see. Should be a picture of what he had in the movie there. There's probably him inside the cage there, but they should show it. There it is. He actually had a large cage with computers on the inside. Okay, so you can shield signals. Okay, it says ensure policies are in place and enforced. That's another thing you can do. If you have a security policy, are you actually doing it? Has anyone edited the device? Like we have a policy here at Rose State of what can be used on the network. Is it being enforced? Okay, how about your home network? Do you have anything there? Physical security says locked doors in rooms containing access to switches. Back when I ran my consulting business, we had a server that stored credit card information. We had to do what's called PCI compliance. And before we could store credit card numbers, we actually had to ensure that that specific server was behind 2 different locks. In other words, to access the server, had to go through 2 doors with locks, and they had to be different keys. Okay? So it says locks on doors of room containing switches, install security doors, large auto doors for data centers, all that kind of stuff. Okay, conduct power sweeps. They actually, Brad Johnson here at Rose State does it all the time. He'll walk through looking for rogue access points. Somebody installed one in engineering a little while back. Okay, another thing right here: shut off all switch ports on computers that are not in use. Funniest story behind that, I think it was Grant Cadiz. I'm not 100% positive. Went to Taco Bueno on 29th and, I'm sorry, not 29th, 15th and Air Depot at Taco Bueno, and at the time they had booths set up, and below the booth was a network jack. He plugged his laptop right in and instantly was obtained an IP address and was on their internal network sitting at a booth. So really you need to make sure all switches, or all ports basically on the switches that are not currently in use need to be turned off. Okay. All right. Now let's talk about some of the different items out there. Social engineering, phishing. I kind of had an email. I don't know what I do with it anymore. Actually, I got one this morning. Let me find it here real quick. Let me search for it. I got it from our president. Here it is. I actually got this email this morning from our ex-president, Terry Britton. I got this email, and if you click on this, it's basically trying to sell me some crap about, you know, fitness and health. And in other words, someone got into his computer system, probably installed a virus or something. I mean, probably clicked on something, and then it's sending out this to a bunch of people, obviously, and I was the recipient of one. Okay. With wireless, now you can actually do what's called ward dialing. You can drive around and connect to wireless networks. There's actually going to be a project on this. I have to finish setting it up. But what I want, I don't know if you know this or not, but when you take your wireless device, say your cell phone, and you drive around, it will actually connect to known or to wireless networks. And they don't necessarily log in, but it will actually connect. And if you bring up Ncase, you can actually see a list of the networks the device is connected to. You will be doing a project on that, so don't worry. Okay, but ward dialing, you can very easily go out and check devices. Now, what they're talking about here is using a sniffer, enabling mainly NetStumbler and a few others, to look for SSIDs that can even be hidden. And you can capture their beacon, you can connect the device, and see what the network is. You can do it even if they're hidden. Okay? Okay. Says, why did I do that? Was weird. Okay. It says, ward drivers typically look for the following. They look for default usernames and passwords. What is the default? Well, I'm going to bring up Mr. Google here. And I'm going to type in link says LINK. The login link says, well, let's see, default username. There we go. Let's get down to this one. Okay. It should tell me. There it is. For these specific models, there's what the default username should be. Wow, look at that. So if I go in here, Here they are. Look at all those. Look at all those default usernames. How many people set up their wireless access point with the defaults just so they can get into it and never go back and change it? Isn't that terrible? 54G, very well. That's 54AG. 54G right here. There it is. Blank and admin. Admin and admin is probably the username for a lot of people. So they could drive around, look for it. They could look for people running web. Okay, they could look for people who haven't changed their SSIDs. You can really, do all kinds of different things. Look for people who have DHCP enabled. Do you really need DHCP enabled? Let me pause this for a second. I'm going to try to get into my home computer. Alright, here we go. I'm actually now inside of my Airport Extreme on my home network, and I can bring it up and I can see that Bethany's got her iPad on, my thermostat's connected, my hub. I can even put this over here and see exactly what the MAC address and the IP address is of the device. I can see my network name. I can go edit. Now I can actually go under network. And you'll notice on me, I do have DHCP enabled, but I have a lot of specific port maps done. Okay. Let's use this one for instance. Okay. I have a reservation set up for my solar system. Okay. And it happens to be right here on port 8080. Okay. Now this is called port translation because externally you connect on port 8080 and it resolves to port 80 internally. So if I went to dewey.mine.new with port 8080, you will see all of my different solar inverters online. Okay. It should. If it doesn't, there it goes. There they go. Now they're coming up. It's a little slow in coming up. You'll see there's all 44 of my inverters. They're online. So what's happening is I am statically, see this device, if I go into administration here, if I go into configuration, where's it at? There it is, Ethernet configuration. Okay, let me bring this over so you can see it. There we go. You see, I do use DHCP on this device, but what I did was this specific machine, no matter what, based on its MAC, is getting this IP address. So I'm actually using a DHCP reservation. So whenever it connects, same with all my cameras, they all do the same thing. Okay. Now let me close this out. All right, there we go. All right. So that's just an example of what a router looks like. It's easy enough there. Okay. But don't use default usernames and passwords. I don't. You shouldn't. Don't use default SSIDs. Just configure it yourself. Again, I haven't DHCP enabled. Maybe not the best thing, but I do have a lot of devices that I just bring on and off my network. Okay. Well, if I can get this slide to continue, and there we go. Okay, war driving tactics is masquerading. This is attackers impersonate authorized users to gain their level of privileges, or replay. They replay packets. This is use the packet analyzer to capture network traffic between hosts. And message modification, they could add, delete, or change, or create a denial of service. Y'all know what that is. Okay. Now let's talk about a couple different items on a wireless network. We could have a road access point. What if someone walked into your network at your house or at your work and just plugged in an access point? There you go. It's now a rogue access point, an unauthorized access point attached to a wired network. So I have one here in my office. It's plugged in. I do have permission. So it's an access point. It's just not rogue. Okay. Normally installed by a hacker. They want to get access to your network. So what if you have some ports, wired ports in your house, and someone just came along and plugged in an access point? Now they're basically in your network. Okay. They can use them. They can, depending on how they're configured, they can get access to your network from that point. Okay. May be added to the network to serve as an attack vector. Okay. Vulnerabilities. They can do scanning. They can do mapping. Kind of like I showed you a few minutes ago where I just did Nmap against my cell phone. But I theoretically could do it against the entire network. And from my cell phone via the wireless, I can actually scan the network. I can't show you the picture on there. But there's a utility out there called Fing, F-I-N-G. And I'm actually scanning right now. I'm going to show you it. Again, I can't show you the application. It's on my phone. It's not on this machine. But if you search for Thing Network Tools, it's free. You can actually download it. It's kind of cool. And come on, there it goes. Mine's scanning now. There's actually a little video. We can watch the video since I can't show it to you. Oh, maybe. That's not what I want. That's not what I want. Go away. Okay. But Fing, awesome little application. You run it, and do they show pictures of it? Not sure they don't. Oh, maybe they do. Maybe they do. There it is. Okay. What you do with Fing is you connect, and then you click the little scan button here, and it will actually scan your network, okay, and show you all the devices on it. It'll show you what they are. You can click on them. You can see the ports that are open. Kind of a cool thing. I ran this on a cruise ship. It's funny. I was on the Carnival cruise ship, and I connected to the wireless. It was like 3,000 connections. I was wondering why the wireless is running slow. Hell, everybody was on it. But kind of a cool application, so if you've never played with it, it's free. It's available for Android and Google. So I guess it's the same thing. iOS and Android. So there you go. You can get it for both. It should show you the page for, there it is. There it is for Apple. Okay, right there. Free download. What it is this tool is free, but there's something called Fing Box, which you can use for reporting that actually costs money. If you've never tried it, try that. It's really a cool little application to run. Okay, but being connected, they can now scan your network. They can run man-in-the-middle attack scan. I don't have the ability to run it right here at this moment, but you will see one throughout your courses, I'm sure of it. They can art poisoning. They can do all kinds of different things just because they're on their network. They can also steal data. Okay, data leakage and theft due to unauthorized access. If your network is unsecured, people could get in and steal stuff. Okay, Evil Twin, a rogue access point installed with sinister intent. Looks legitimate. So my access point at home is called Secured. I don't know why I just picked that name. I actually changed it quite a bit. But what I could do is rename it. Rename it to my neighbor's name, whatever his is. D-Link something. I can very easily rename mine to his. Or what if I took one up here to Rose State and named it Rose State? Then if you want to connect to it, you'll actually be connecting to it to me. It says the attacker poses a genuine network service provider. Users connect to the Evil Twin. Users to access websites, perform all this stuff. All along, their stuff can be eavesdropped, can be captured, can be looked at. Okay. All right. Setting up. Look for the SSID or the SS, basically the same thing, being broadcast. Set yours up with the same one. You can use Airshark, you can use NetStumbler, a lot of different applications, and people think you're real. A good one to see for that is free Wi-Fi. Go to the airport, next time at the airport, look for how many are called free Wi-Fi. There's always somebody who's doing it. It's probably somebody with their phone in ad hoc mode rather than infrastructure. We'll talk about that later, but actually I think it was already talked about. But ad hoc mode means you would be connecting to my device rather than an access point. So what if I was to connect to that free Wi-Fi? Then they could be getting data off of my device. Okay. Different technologies. Bluetooth. Short range communication. 2.4 gigahertz. And it's funny, we actually were testing the wireless in my office the other day. Not Bluetooth. We were testing the wireless while I was cooking lunch. And I had totally forgot that microwaves work on the same exact channel. Okay. So just by cooking my lunch and I was standing next to the microwave, it actually cut my traffic massively down. Okay. All right. It uses frequency hopping. It's a very low distance, but the Lord Lewis actually perfected it to go up to 300 feet. It says connect up to 8 devices for PicoNet. It's just a very easy way of communicating. Okay. Authentication, confidentiality, authorization. There's really not a lot in there. You set your device up for scanning or to scan someone else, and then people can connect at the time. Okay. You can scan others Bluetooth if they have enabled. Mine's enabled because it connects to my watch. Not the most secure thing, but mine is not set to scan at all times. Okay, We have different modes. We also have what's called trusted or untrusted. It says trusted device has full access to all services on another trusting device. So my watch and my phone work together. There's a trust between them, so I can access. They basically can both access each other. Untrusted devices do not have an established relationship and can only reach through restricted services. So actually, that I don't know exactly how my watch is connected. It could be untrusted. I'm pretty sure it is trusted though. But with untrusted, you can only access certain services. Okay. Modes 1 and 3, no service security trust model is applied. It says mode 2, authentication, encryption, authorization are required. You would actually have to log in with that. Excuse me. Hold on a second. Sorry about that. I had to cough. Okay. So on these different levels, like it says, level 3 requires man-in-the-middle protection and encryption, along with user interaction. Level 2 is encryption only. Level 1 is encryption, no interactions necessary. So just different levels of Bluetooth security. And I lost my mouse again. Okay. There we are. Bluejacking says the misuse of Bluetooth features whereby a mobile phone could exchange a business card or messages with another phone in the vicinity. You can kind of think of it like AirDrop for Apple. We have the ability to transfer stuff back and forth. Okay. Can use by malls, for example. They can make it where when you go into the mall, they could send specific advertisements to your phone, like to say spamming here. So devices need to be peer before communications, okay? And you don't really, it just happens. You don't necessarily know about it. It's like it's saying here, it's more like spam, okay? It says after the initial message was accepted, the Bluetooth device ID was added as a trusted contact, and then you continue to get more junk. There's other examples of that. One is Waze. If you ever heard of Waze, it's not really Bluetooth, but it's kind of the same thing. When you're traveling in certain vicinities, it will show you advertisements based on what is, based on where you're at. So if you're, right around a Taco Bell, it could show you a Taco Bell advertisement. Okay. All right, blue snarfing, a little bit different here, but now it's where people connect to your Bluetooth. They can access your calendars, they can access your emails or your text messages like it says there. But you have to be in discoverable mode. Not a good idea. And the devices must also pair. I watched Person of Interest, a TV show. If you've never seen it, it's kind of funny. Or not really funny, but it's techie. It's kind of good. But they're always doing this. They're always pairing their phones with other people. The phone has to be in discoverable mode before it'll happen. So a lot of stuff, when you see that on TV, it's not real. Okay? All right. All right. Blue bugging. Blue bugging is basically taking over someone's headset. Okay? It thinks it's you, and it basically gives you all the commands. You could actually make phone calls. You can actually do everything with it. Like it says here, it's actually commandeer your entire handset. Okay. Is it vulnerable? Yes. Okay. It says it's a a trade-off between convenience and security. It's good, but first of all, it wastes battery, but it does leave one. It's kind of like leaving one more door. The door might be locked even, but now we know you have a door. Okay. They always use short pins. Now my watch, when I paired it, actually uses the QR code. But it makes our life easier. But yes, it is basically not as secure. Okay. Packet analysis, we can use different things. They say Wireshark, that's basically what I showed you earlier. AirShark's another version of it, where you can actually look at packets. It says running AirShark, wireless network cards enters promiscuous mode. This is the same thing here. My machine went to sleep. Anyone know what the password is? It's a joke. Okay, but when I ran this Wireshark right here, what it did is it put my network card into promiscuous mode. I'm going to start it again, okay? I'm going to connect to my ETO0. Now, I'm actually doing nothing on this device, okay? I am not causing any traffic or anything, but you'll notice I'm getting traffic. Why am I getting that traffic? Well, because my device is now in promiscuous mode. So any traffic that destines for broadcast, I'm getting, okay? Now, if I was to actually do something, you would see more, okay? But this is promiscuous mode. I'm getting this data without actually doing anything at all. Okay. That's what it does. Puts it in promiscuous mode. Captures all packets it sees. Okay. Okay. Understanding. All right. Oh, that's right. We did them all. We already talked about information theft. Actually, yeah. So we pretty much covered everything for this. Now we're going to talk about your project. I will have your project up shortly. So look for some information on that.